Hey everyone. All right, today we're going to be talking about effective ways to build AI native products. AI is a buzzword that's thrown around a lot. In the context of this call, we're going to be talking about products where AI is the critical component. So this means it's being used to reason, make decisions, and potentially take some kind of action. The techniques we're going to talk about are to build functional AI applications. That means the end product needs to be business ready, reliable, and actually work consistently. I'll also be sharing some real-world examples of products we've built using some of these techniques. To start with, I'd love for some volunteers to share what they're working on in the comments or in the chat below. Just one or two lines briefly explaining the application is sufficient, and I'll try to make the stuff we talk about as relevant as possible to those examples. Before I dive in, I want to quickly introduce myself. I'm the founder of Byldd. We're a venture studio focused on helping domain expert founders build and scale tech businesses. So we partner with founders and give them a complete technical team to help execute on their vision. The founders we work with typically have 10 to 15 years of experience in their space. They've seen some kind of opportunity there and they want to build technology to commercialize it, and we help them do that. The idea is to reduce the friction that bootstrapping founders currently have when they're trying to build tech. Awesome. So here are the 5 techniques we're going to be covering on the call today. I want to quickly cover how LLMs work and some of their existing limitations. Many of you may already know this, but this is a quick recap for the ones that don't. LLMs work by training an AI model on the data of the internet. This presents two main problems. One is that there's obviously a limit to the amount of information any model can contain. The models that exist are generalistic models and they're probabilistic in nature. So they tend to share the generic popular opinion on any topic and have a surface level understanding of most subjects. The second is that there are cutoff dates for training. For example, the most recent cutoff date for ChatGPT is October 2023, which means it's not been trained on anything that's happened after that date. The off-the-shelf AI models are smart in a general sense, but general is often not good enough for businesses. As a business, you'll typically need specialized domain expertise, whether in medicine or law or what have you, or need industry or company-specific knowledge to make decisions. That's where some of these advanced techniques come in. To start off, we're talking about RAG. So RAG stands for Retrieval Augmented Generation, and it's a technique that adds a real-time information retrieval step to your run-of-the-mill LLM. That means AI doesn't just rely on what it was pre-trained on, it actively fetches from external data sources, such as a company database, documents, or the web, before generating a response. So this ensures the AI's answers are grounded in your data or the latest facts, making them more accurate and context-specific to your needs. It's like someone doing a search of your internal database or the internet before giving you an answer and citing where that information came from. RAG significantly improves the accuracy and relevance of AI-generated content. So it solves the cutoff problem, reduces hallucinations, and allows you to leverage private or proprietary data. Instead of retraining your whole model on your company's documents, you can keep a lightweight retrieval database of those documents and have the model consult it on the fly. This is often much faster and cheaper than fine-tuning a model with the same information, and it lets you hot swap or update data easily. For example, updating the knowledge base with new docs immediately makes the AI smarter without having to retrain it. This technique is also called knowledge grounding because the answers are grounded in your data. We've used RAG in a number of fields. For example, we've built virtual patient AI to train student doctors by pretending to be patients and progressively explaining symptoms and answering questions. Or in finance, RAG allows users to ask questions like, compare a Wendy's franchise with McDonald's and tell me which would be more profitable in so-and-so zip code. Because it has a knowledge base with all of that financial data that's not easily available on the internet. Now, fine-tuning solves a similar problem to RAG, but in a different way. Fine-tuning essentially updates the model itself so that it learns the patterns in your data. So instead of fetching information from a third party, the model knows it inherently. It's like teaching an employee who has a general skill set to perform a specific job really well. This is definitely a more expensive alternative to creating RAG, especially at the training stage, but it becomes cheaper and faster at the execution level. Think of it as updating the operating system rather than creating a database. So you should consider fine-tuning when your AI needs to understand industry-specific jargon or content. This is very popular in the medical field, where there are several terms that the model is expected to know inherently. You should also consider it if you want a consistent brand voice or style. For example, if your startup has a quirky, friendly style in all of your blogs or support replies, fine-tuning the model on examples of past written content will make it consistently adopt that voice in future outputs. Another place to implement fine-tuning is if the model isn't performing well on tasks with basic prompting. Providing examples of correct input-output pairs via fine-tuning will increase accuracy. So fine-tuning essentially teaches the model the exact task by repeatedly giving it examples of the ideal output. The big advantage of fine-tuning is quality and customization. The model itself remembers the specifics of your data. It can exhibit expertise that the base model didn't have without needing to look things up like it would have had to with RAG. This also means that fine-tuning models can accurately imitate more specialized employees rather than the most junior ones. On the flip side, fine-tuning requires a suitably sized dataset and some technical work. So you need a decent number of examples, and there's a price associated with training that model. There's also maintenance. If your knowledge or style changes, say you enter a new market with different terminology, you'll need to retune the model. Because of these trade-offs, a good strategy is often to start with RAG for quick wins and invest in fine-tuning when you're seeing consistent patterns that the base model isn't handling or when you've accumulated enough high-quality data. On the implementation side, you could start with off-the-shelf models like ChatGPT and train them via API, or fine-tune open source models like Llama and deploy them yourself. There are pros and cons to both approaches, as pricing becomes a major consideration after a level of scale. Now let's talk about AI that takes action. Agentic AI is software that can autonomously perform actions. The key capability that allows this is called tool calling. Tool calling is the ability of your AI software to interact with external tools. So this is a big shift from what we've been talking about before. Our AI tool just moved from being a passive assistant to an active agent that can affect the real world. For example, if you were hiring candidates and wanted to book interviews, a correctly programmed agentic AI would recognize this as a task requiring action. It could check your calendar's availability, find the candidate's contact information, and actually send a calendar event or send an invite. Or it could use Twilio to call them, check their availability, and then schedule those calls at a time where you're both mutually available. The AI just became your new best friend for hiring. The really exciting part is that there are very few limits on what tools these AI agents can use. And there are new tools popping up every day. There's a world of possibilities. Some of the agents we've built are sales agents that can automatically take prospects from your CRM, research them, and send highly personalized emails that exactly match your brand voice and tone. Or data analyst agents, AI can plug into your database and Power BI or any other BI tool, crunch the numbers, and generate a dashboard based on a few lines of verbal instructions. There are some challenges to this. Building agentic AI requires careful design. You have to set boundaries, which tools and actions it's allowed to take, and also thoroughly test the decision-making logic. Things that may seem obvious to you may not be obvious to AI. The solution is to start with a human-in-the-loop approach for critical decisions. So there's a check before execution, mistakes get recorded, and then the AI gets trained again on those mistakes to avoid them. Eventually, you can grant full autonomy, and then it's gonna make Skynet. So now, when you start designing and implementing these techniques, you'll realize very quickly that managing those workflows can get very complex. This is known as the orchestration layer. So these are techniques that can help you build and manage complex AI workflows. It covers things like multi-step workflows, tools, sub-agents, the works. There are a couple of other companies that also do this. AWS, Google, Microsoft, and OpenAI just yesterday released their Agentic AI builder. All have their own offerings, but LangGraph is currently the best in class for this kind of stuff. From a usage perspective, it's like building a flowchart with a flowchart builder at the simplest level, though it gets more complex the deeper you dive into the functionality. The idea is that now you can control every step of the decision-making and execution process for the AI agent, which is a much finer level of control than you'd get from just prompting. For example, we've built a recruitment platform that uses Twilio to call candidates, interviews them, grades them against a hiring matrix, passes or fails them, and then schedules the next interview on the hiring manager's calendar, replacing an entire junior recruiter. This is a multi-agent workflow where you have multiple different AI agents interacting with each other. And the orchestration layer on LangGraph is where the brains of the entire operation live and where all the decision-making happens. The main benefit here is that you can build really complex decision-making workflows and action workflows, and it gives you the transparency to debug them and improve them at a very granular level. So this lets you have agents that can interact with each other, perform complex tasks like recruitment or stock trading or pretty much anything else that has some kind of inherent logic to it. The last thing I want to cover is MCP. This stands for Model Context Protocol. You can think of MCP as a universal adapter for AI. This is the protocol AI agents use to talk to tools. So for example, if you want to connect your AI to Canva behind the scenes, it's actually connecting to Canva's MCP server. This is what allows you to enter prompts like design a birthday card on Canva and have it actually talk to Canva and get the desired output. The goal of MCP is to make AI integrations plug and play as much as possible. This means the AI doesn't have to know the nitty-gritty of each tool's API, it just speaks MCP. And because the tools also speak MCP, they can talk to each other. So why is this important? There are two ways of thinking about this. So on one hand, if you're making the AI agent, tools can be swapped or updated behind the scenes as long as they maintain the MCP interface. For example, if you're using SendGrid and want to use MailChimp instead, you can just swap them out instead of building an AI integration from scratch because there's already an organized communication layer. On the other hand, if you have a SaaS tool, it's almost become table stakes now that you need to create an MCP server to allow AI to interact with your application. For example, if you're building a SaaS CRM, building an MCP server not only makes it easier for you to build a chatbot UI on your own front end and give your users the capacity to interact with the platform via prompt, it also allows users that are already using Claude or ChatGPT to directly connect with the CRM from their AI clients. This is becoming more and more of a requirement as users have personal AI workflows or are building their own agentic systems. So this compatibility becomes a purchasing criterion. The third benefit is that if you're building an AI agent that needs to connect to a tool, but that tool doesn't have an MCP server, you can spin one up yourself as long as you have API access. And so there's a host of community-built open source MCP servers for pretty much all of the popular software platforms. So this really reduces the limitations on what AI can interact with. So yeah, these are some of the tools that exist that allow you to build very interesting AI software. It's a very exciting time, and with proper training and orchestration, there's very little AI won't be able to do. Feel free to send over any questions you have in the comments below or to reach out to me on my email on the screen, and I'll try to get back to you as quickly as possible.